So here's the second example I'm going to do for you guys. Just like the last one, I'm going to strongly suggest that you guys pause it, try and figure it out, or at least draw the picture, do as much as you can without me, and then start watching the video again. Or if you do finish the problem, go ahead and skip to the end and see if you got the same answer as me. If you did, then great, you got the right answer. If you didn't, then skip on back, try and find out where your mistake was. As soon as you find out what that mistake was, try and continue that from the end, and just keep on going, just so that you build up that little independence there. So go ahead and take a second to pause the video and see what you can get done. So ideally at this point you've taken a moment to pause the video and try it out. Remember, the first step is always to be able to understand what's going on here. So in the beginning we have Dash starting his 100-meter dash. Then he runs, and he's going to be constantly accelerating until he reaches a specific speed. After he reaches that speed, he's going to maintain it until he finishes the race. So here's him all excited finishing the race. So really here, this is going to be a problem where we have three distinct time points. At 0, he's starting the race. At 1, he's kind of finished up and reached that maximum speed. And then over here, he has completely finished the race. So what we need to do is we need to look at these positions and the velocities at all of these locations. Position 1, velocity 1. So over here is position 2 and velocity 2. So at position 1, since they never actually specify where our 0 is, we're allowed to choose it wherever we want. So I'm going to go ahead and choose that our initial position is 0. And since this is a 100-meter dash, hopefully he's starting from rest. If he was starting from some other speed, that means that he started out here, and then right at the start he started running, which would mean he's cheating. So we're just going to assume Dash doesn't cheat. Over here, this specific time point was actually when he reaches that speed. So we know at this point his speed is 9.6 meters per second. And if he listens to his dad's advice, he's going to keep going at that speed, 9.6 meters per second, until he finishes the race. So we don't know when it is that he reaches this, what position it is, but we do know out here he's finished a 100-meter dash. So now we got to look at the time points here. So this is going to be time from 0 to 1. And again, we don't know what that is. Just as a quick heads up, if you don't feel like writing T0 to 1, you can also name it time point A, or you can name it time point something else, as long as it's something that's obvious and specific to this time point. That way you don't get this time point mixed up with this one. We also need his acceleration from 0 to 1, and this can also follow the same law. You can say A sub A if you really want to save just a little bit of space. So we don't know how much time it takes him to reach up to that speed just yet, and we don't know what his acceleration is just yet. Oh, I'm sorry, nope, we do know what time. It would help if I reread the problem. It says that it takes him 2.14 seconds to reach that speed. 2.14 seconds. But we don't know the acceleration, so I was telling the truth on that. Over here, behind time points 1 to 2, we don't know how much time it takes him to do that, but we do know that the acceleration from 1 to 2 is going to be 0 meters per second squared. If he was accelerating, then that would mean that he's not keeping that constant speed. So this section over here is a constant velocity problem. And again, just like I said in class, constant velocity equations are very, very easy to look at. You might have them already memorized, but if you've forgotten about them, you can derive them using the other three equations we saw in class. Just set the accelerations equal to 0, and suddenly all of there are your constant velocity problems. So let's go ahead and take a look here. What we eventually need to do is we need to find out his time between 1 and 2. This is the ultimate goal. But I see that there's a lot of blanks in here. So the equations that use time, if you look at all those equations, you're going to find out that it's not possible for you to figure it out with the information given. So the information that we need to solve in order to figure this out is going to be our x1. So let's see if there's some way that we can figure out our x1. If we list out all of our haves and all of our wants, again, it turns out we can't figure out our x1. What we eventually need is our acceleration. So we need to end up finding out 1, 2, 3 things before we eventually find our answer. So this is going to be a little bit more of a complicated problem. So just real quick, what I would do if I were you is pause and see if you can find an equation that would work for T1 to 2. Now that means you can only use this information here. Since we're specifically looking from the time point between 1 and 2, we have to disregard 0. And when you look at this, there's no equation that'll give you T1 to 2 without more information. So we would either need to have an acceleration, which would totally ruin the problem, or we would need to find our x1. So we decided let's find our x1. So if we can't find x1 using time point 2, let's find our x1 over here. And again, if you look at all those equations, there's no easy way to find that x1. Every equation that we come across would need acceleration. So let's go ahead and take a look. And if you're following along, you might have realized that you can find the acceleration by using our final velocity, or v1. Sorry, there's no such thing as a final, I guess, at this point. v1 is equal to v0 plus a from 0 to 1, t from 0 to 1. Just like always, make sure you plug in your zeros first. v1 equals a from 0 to 1 times t from 0 to 1. So now we rearrange before we plug in. We need to divide both sides by t from 0 to 1 divided by t from 0 to 1. And we end up with v1 divided by t 0 to 1 is equal to the acceleration from 0 to 1. Plugging in a few numbers, we end up with v1 being at 9.6 and t being 2.14, giving us an acceleration. Give me a moment to plug this in. 9.6 divided by 2.14, giving us an acceleration of 4.486 meters per second squared. So 4.486 meters per second squared. We now know this number. Again, ideally we wouldn't use this information to calculate the rest, just in case we made a mistake, but in this case it's a little unavoidable. So the next thing we need to look at is find that x1. The whole reason we found the acceleration was to find x1. So looking through our equations, we find out that the proper one to use is going to be, x1 is equal to x0 plus v0 t from 0 to 1 plus 1/2 a from 0 to 1 t from 0 to 1 squared. Plugging in our zeros, we get a few things canceling out, which awesome leaves us with x1 is equal to 1/2 a 0 to 1 t 0 to 1 squared. We have already rearranged to get our variable by itself, so we can just straight plug in numbers. Acceleration is that 4.486. Our t is 2.14. Don't forget that squared. A lot of people end up forgetting that squared, which leaves me with an x1 value of 0.5 times 4.486 times 2.14 squared gives me a whopping total of 10.272 meters, which means this value right here is going to be 10.272. So close. So again, we found x1 because we needed that to get t1 to 2. Now as we're looking at this, we've got the ability to use x2 or time point 2 now. So we've solved for everything for time point 1, time point 0, we've solved for everything for time point 1 except this t, which is good because that's what we need. So looking through our equations, what we have and what we want, we can say x2 is equal to x1 plus v1 t from 1 to 2, 2, plus 1/2 a from 1 to 2, t from 1 to 2, quantity squared. Plugging in our zeros, well, the beautiful thing is your acceleration is 0. So all this big old mess at the end there cancels out. And we end up with x2 equals x1 plus v1 t1 to 2. Doing a little bit of rearranging, we are going to subtract x1 from both sides. x2 minus x1 equals v1 t1 to 2. And at this point, I'm going to scroll it down just a little bit. I'm going to go ahead and divide both sides by v1. And I am left with a final equation of x2 minus x1 over v1 equals t1 to 2. Plugging in the proper numbers into our calculator, x2 is 100 minus x1, 10.272, all divided by v1, which if we look up at our chart is 9.6. Plugging that into the calculator, be very careful. This tends to be where some people make mistakes just plugging into the calculator. Be sure that this top goes in parentheses. If you don't put the whole numerator in parentheses, then what your calculator is going to do is it's going to take 10.272 divided by 9.6 and then subtract that from 100. So just be very careful with how you plug it into your calculator. The correct answer you should end up with is that t from 1 to 2 is equal to 9.34, and then we've got 6 repeating, so I'm just going to truncate it and say 6 seconds. Now at this point we're so close. We've solved for all the things, but we need to make sure that we're answering the question. It says what was his total time. Well, his total time is going to be the amount of time it took to go from 0 to 1 plus the amount of time it takes to go from 1 to 2. So ultimately my final answer is going to be 2.14 plus 9.346. Punching those into the calculator, 9.346 plus 2.14 gives me 11.486. So still a very fast time, but not quite as fast, or not quite unbelievable for Dash's standards or for a middle schooler standards.